Okay. So we're going to finish up with then today is just a discussion about thinking about this whole idea of why is it that lifespan being longer than what Mother Nature actually intended us to have creates such a problem in terms of cancer being something that we now have to deal with in our modern lives that generations and generations before, right, 1,000 years ago, 20,000 years ago, cancer was almost not an issue at all. So if we look again at our comparison of the lifespan of a mouse compared to a human, and so we go up to the top here, let's imagine that this is a normal, healthy stem cell in the mouse somewhere. It begins to divide, right? As it divides, this one over here gets a hit. So this red one over here now can be thought of as the founding cell of a pre-malignant, maybe tumor. And so all of these cells over here are still the normal differentiated cells and tissues in the mouse, and maybe the mouse has this cell over here that's starting to go bad, right? It's starting to go rogue. So it divides some of its daughter cells. Most of them probably do the right thing and undergo apoptosis, but maybe it starts building up additional transforming mutations, okay, to the point where now maybe it would really be classified as a tumor cell. Not cancer yet, right, but just some sort of a benign tumor. As far as the mouse is concerned, that's okay, because guess what? At this point here, that's the end of the lifespan of the mouse. So again, the mouse hasn't had to worry as much about this issue. But for us, if we follow this now past the lifespan of the mouse, right, we live something like 30 times longer than the mouse. And so that comes with its price. And the price of extra years of life means extra time for these benign tumor cells to keep going through the process of transformation, right? Eventually then leading to malignant tumor cells. So this might make you realize then that when we talk about different types of factors that are considered risk factors for cancer, I think a lot of times if we said, well, what are some risk factors for cancer that epidemiologists might know very well and classify, we might say, oh yeah, smoking, UV exposure, right, like not wearing sunscreen, or maybe exposure to different types of carcinogens, like in the workplace, like an asbestos that's in the old ceilings and walls of an office building. But we never really think about just the fact that being alive longer is a huge risk factor. And if you were to look at this figure on the screen right now, it might actually make it appear that just simply being alive longer is the biggest risk factor for cancer. And that's true, because ironically, us being healthy and living longer, our longevity itself, our age is the greatest risk factor for cancer, because most cancers take decades to develop. Statistically speaking, a 70-year-old is 1,000 times more likely to exhibit cancer than a 10-year-old is, simply because they've been alive 60 years longer. If you look at this data down here, this is comparing the rates of different types of cancer in men on the left and women on the right. You see that these different colored lines represent things like prostate cancer or lung cancer, urinary cancer, colorectal cancer, stomach and pancreas. You can see that all of these cancers jump up tremendously in terms of rates once you are past 45. And that is the magic number, because again, remember, Mother Nature only built us with the intention of our lifespan being somewhere between 30 and 40 years old. So one way of thinking about it is that by staying alive longer than 45 or 50 years, we are pushing our bodies well past the warranty. What our different cells and tissues came equipped to expect in terms of how long they needed to worry about fighting cancer, we now exceed them. I mentioned to a couple of you that, these days I'm really grumpy about modern electronics that you can buy in places like Best Buy or whatever, because it seems now you buy a new flat screen OLED 4K TV for like, I don't know, $600 or something like that. And then it just like dies after a couple years. Right? Whereas my old TV that I bought like 20 years ago is still working fine. Right? And that's because these days, the components that make up the new TVs are all really cheap electrical components, capacitors, resistors, things like that. Because in order to keep prices down, the manufacturers just use cheap components. Why? Because they know that the life expectancy of 2 years now for a TV is considered normal. So if you get more than 2 years of use out of your flat screen TV, you're already doing pretty good. They just expect that once that thing breaks, you're just going to go buy the next greatest TV to replace it, right? So our bodies are like that as well. Mother Nature and evolution designed our components, meaning all the different types of tumor suppressor genes and things like that, and the functioning of our genome, to expect that we could be around for 30 to 40 years, anything beyond that, right? And you're out of the warranty. And so that's why if you look in men, certainly that's very clear. The cancer rates jump up tremendously after 45 years. In women, that's much the same as well. Keep in mind that the y-axis scales on these are different. So in other words, women, if it maxes out at 500 over here, on the left, that would be somewhere over here, okay? You can see breast cancer, right, does start earlier, but for the most part, again, after you've aged past 35, certainly past 45, right, the rates of these different types of cancers go shooting up. So this raises an interesting question then. So you'd think then that as we are living longer, there should be some natural selection then for different genes that can reverse cancer. We've talked a lot about why we have tumor suppressor genes that prevent cancer from forming in the first place, but why don't we have good genes that can actually reverse cancer and undo it? If we think that our bodies really have amazing restorative powers, we're all familiar that if we cut ourselves, our wounds heal, even our bones, when they're broken, they can heal. Our immune system is very powerful and protects us from infection. So when we suffer from a bout of some illness, we can fully expect that our immune system will heal us, right, by eliminating pathogens and disease from our body. So why then can't we reverse the process of tumor formation? I mean, that seems kind of obvious, right? Wouldn't genes that can reverse the process of tumor formation be selected for? So we can think about it this way. Why doesn't evolution favor cancer reversing genes? And this has a lot to do, again, with what we were just talking about in terms of what Mother Nature intended for our lives to be like. So let's say we think about a typical lifespan in modern society, right, from age 6 months up to 90 years old. You would think that if we're saying that after 30 and after 50, the incidence rates of cancer skyrocket, just because our bodies were not built to kind of go beyond that in terms of what Mother Nature expected, then why don't we see selection then for people who actually have really good alleles of genes that can somehow reverse tumor formation? Does anybody have a thought about that?
Most people have reproduced at that point, so there's no selection?
That's exactly right, okay? So if you think about it, the genes that actually get passed on from you to your offspring, right, are the genes that you happen to have good alleles that impart fitness. I'm not talking about fitness necessarily like physical fitness. I'm talking about genetic fitness, meaning you have the combination of different types of phenotypic traits that reflect what sort of genotype you have, right? And the more traits that you have that are considered desirable, the more chance there is of you actually having kids, finding a mate and having kids. And so that means the genes that impart fitness and the alleles that you have that make you fit for reproducing are the ones that are emphasized all the way up until you have children, right? And in a way, the fact that you have those alleles, they've done their job. You're able to pass those alleles on by having kids. But when does cancer become an issue? Cancer is not an issue typically from birth to 30 or 40. As we've learned today, cancer becomes an issue past 40, because that's when our bodies are now going beyond what we are actually designed to endure. So that means if you had genes that were actually really good, like alleles, genetic variations of genes that were really good at somehow reversing the formation of tumors, this is the phase of your life when those actually become important. And so those people who have those might have a better job then of actually surviving beyond that. But the problem is, those are not the genes that mattered to get you to this point here of having kids. So even if you have wonderful, wonderful alleles of genes that fight cancer here, right, it doesn't necessarily mean that they are combined, that you also happen to have great, great alleles that give you the fitness that actually favors you reproducing. So that means natural selection considers these genes over here to get you up to the point of having kids, but in many ways, natural selection ignores any genetic variations that make you particularly good at fighting cancer. Okay. So it's a really interesting thought. This whole right part of the screen here is just a result of the success of human beings as a species. We control our environment, we control our food, we control our health through modern medicine, and all of this has pretty much happened in the last couple hundred years. So a couple hundred years compared to millions of years of evolution that fine-tuned us to get to this point here. Obviously, there has not been nearly enough time for any type of selective pressure to be placed on us fighting cancer well after we've already started developing it. Okay, so any questions about that? All right, so what I'm gonna do is I'm gonna go ahead and stop this recording.